So the very first question is, what is permanent formwork? And it is literally, that's why we chose the name, literally what it says. It's formwork that just stays there for the life of the building. So the idea is that that formwork becomes part of the structure or part of the finishes, and it stays in place. So you don't have any lost formwork, you don't have any clean up afterwards. You stand this formwork up, cast a reinforced concrete wall inside it, then there may be some setting and finishing, and that is your finished wall. The idea is that it's fast, simple, speed the cycle times between the floors, reduce the waste, save in materials, and just get a reinforced concrete wall. So really, fundamentally, it's two different concepts. There's the formwork, and then you think of it as formwork and as a reinforced concrete wall. The reinforced concrete wall is designed as per AS 3600 with some specific measures for some of the embedded items, but it is essentially a reinforced concrete wall. The formwork is underneath the formwork code, and really because it's supplied by the manufacturer, we're supplying most of the methodology, the work method statements, the detailing and the methodologies for how to assemble it. So there's a whole system to doing these walls. They've been around for a long time. Logic Wall and other walls, they've been in Australia for 20 years. They're the sort of the fibre cement systems. There's other systems in place. The recent innovations are the PVC systems. They're the ready wall that CSR makes. They've been in Australia for about 5-7 years. But really they're based on technology from Canada, where it's got about a 30-year history. So there's been a lot of ongoing development with all these systems, a lot of history, a lot of work in optimising these systems. So what you end up with these systems is a reinforced concrete wall. You've got high capacity, you've got your finishes, you've got the optimised methodology to get these walls in. You've got all the BCA compliances, the NCC compliances, fire acoustic, thermal durability. So it's a systems-based approach. And just as an example, we've just one of the more common substitutions with the PVC systems is with block work. And in fact, you can actually consider block work as a permanent formwork system, because it's a form into which you pour concrete. But in the case of block work, the effective area of that concrete is a lot less than the typical permanent formwork systems, the logic walls and the ready walls. There's a lot of different procedures for doing that. The whole idea is you get very light prefabricated assemblies. You're installing the steel on site. The heavy elements of the concrete are pumped in. So you've got to get a lot of advantages in transport and craneage usage. And a really significant waste reduction. In the case of block work, the substitution can be quite simple, in that the permanent formwork, typically, the fibre cement systems have got a 6mm wall thickness. The PVC systems range a bit, but they're generally sort of 1.5, 2mm thicknesses. So you get a very effective concrete width, whereas block work, you're getting a lot thinner concrete section. So a straight substitution rather than a redesign of similar reinforcement, similar concrete, you're actually getting a 40% or thereabouts increase in strength. So a simple substitution for a lot of blockwork walls is quite often a very easy way to go. You can do a redesign, get some reinforcement savings, maybe a bit of extra height if you need it, but often in these residential style projects what they're looking at is a quick solution. Similarly, in the straight vertical capacity, what you're looking at is a greater effective concrete width. So again, you get a substantially greater load capacity out of these walls compared to blockwork. And that's even with the latest revision to the blockwork code and the AS 3600 concrete code. So those two simple factors of bending and axial compression show you that these walls can be quite effective in the straight substitution. There are also a lot of other factors that we've got in the design manuals when you're looking at shear, stiffness, core detailing. We've got ways, most of these walling systems involve embedded items in the concrete, and they can have effects on shear capacity, and you've there's methodologies to determine the impacts on those strengths and the behaviours of those walls. But in general, the market is for lightly loaded axial capacity walls and in-ground retaining walls. And the smaller component of the market is the heavily loaded core walls and other types of walls. So we're sort of focusing here on the lighter loaded walls. And this is just a sample of a straight substitution of a standard blockwork wall, of which there's design charts everywhere for standard blockwork. It's one of the reasons, it's the most common retaining wall design out there in the industry. And you can just simply substitute the equivalent thickness for that block wall with the similar Rio. The detailing changes that you have is that when you're substituting it with the PVC systems, you've got a PVC skin, and that's acting as a membrane. So in the majority of cases, you don't need the membrane that you would need for the blockworks systems. I don't like to say these walls are waterproof. There's a lot of people going around saying these walls are waterproof, and it implies that the whole wall is waterproof. I prefer to say that the water resisting element is that membrane system on the outside, and then that highlights the fact that you've got to actually address that transition at the base. If you've got a water issue there, you've got to make sure that base joint is also treated. Now, the majority of residential retaining walls are well drained, and that isn't a huge issue, so you can do nominal waterproof details. But when you get into hydrostatic basements and big water heads up at sort of 2 or 3 metres, you really have to address that detailing to make sure that you get that waterproof joint. And this is just a close-up of just a typical residential single-storey or 2-storey basement with a hydrophilic base joint and the PVC just acting as a membrane. But you will also see that all the drainage is in there, the gravel backfill, so that you don't end up with a substantial waterhead against that wall. And that is probably 90% of the basement systems that these systems are being used for. The advantage of these systems is just the reduction in the labour and the materials. They're manufactured on site, they come in pallets, they're easier to move around. There's standardised systems for erecting them, bracing them, pouring them. And with all of these systems, the comparison's been done that the erection is nearly sort of twice as quick. There's some figures there that 37 minutes per metre of wall compared to 16 minutes per metre of wall. And that's with a smaller crew than in block work. You can do similar comparisons with precast and in situ walls as well, but for this we've elected to do it on block work. The other big difference there is the actual panel weight that is being moved. In block work it's the bricks, so every metre of that wall is about 200 kgs of material being manhandled around the site to erect that wall. With the PVC systems, it's 12 kilograms. And that's why the work crew is so much smaller and you can get those speeds. We've also, because we're doing so much of this, we've come up with standardised methodologies for erection and bracing and getting the flexibility. These sorts of walls, they're usually built after the excavation is done, so they don't replace shoring walls where you put the wall, dig the wall in and then do the excavation. So you're looking at construction sites where you can get temporary batters in, or you can actually get a temporary vertical face. But that's often the case, and where you can do that, there's different methods that you can use to build those walls, and those either off the floor level, the ground level, or the basement level, or actually drop it in from the deck level. And each state and each builder has preferences. In New South Wales, the preference is to do it off the deck, because the deck can then be used to install all the vertical bars and the concrete. Whereas if you do the full erection off the base slab, you then need to do the vertical reinforcement and the concrete off a scissor lift or something. But you can do it either way. And these systems, they can either clip together or slide together and be very quickly erected with the reinforcement slipped into place as the wall goes along, ready for the concrete to go in. And that brings up one of the issues that's quite often brought up with these systems, and can be an issue because it's poorly defined, and some of these systems are put in by inexperienced installers and they don't take care with the location of the reinforcement. We prefer to use experienced installers and offer training, but some of the other systems, they are going in at remote sites with very inexperienced crews. Unlike in situ walls, you don't have access to the bottom of the bars to tie them into place. So you have to have systems in to locate those bars from the top of the wall. So what we typically do is a combination of lacing those bars, U-bars or ties. And what that means is that these bars, the horizontal bars, are located by the actual openings in the webs. That locates the horizontal bars, and then the vertical bars are dropped in, and in the bottom third of the wall the reinforcement will be one of the horizontal bars or two of the horizontal bars, depending what's required, will be laced onto the other side of that vertical bar to hold it into position, either in a doubly reinforced or a singly reinforced wall. And something similar will be done up the top, but up the top you've also got the option of a traditional tie or other methods. We also use spacers down the bottom of the bars, or you can tie the two verticals coming down with a simple R6 U-bar so that they're held in position against the outside bars. And this is especially critical when you're getting into more critical walls like core walls and substantial retaining walls. One of the advantages that these systems have, especially the PVC systems, is that they've actually got a lot of crack control inbuilt within them. So you can actually get reductions in the horizontal reinforcement for shrinkage crack control and thermal crack control. We've done a paper on this because there is a push from the builders in some of the industries to actually eliminate the horizontal reinforcement in some of these walls. Theoretically, that's possible, but you've got to take great care because there's other things, other code requirements can come in, and especially with retaining walls, especially under the new AS 3600, I don't think it's possible anymore to delete the horizontal reinforcement. You need that as distribution reinforcement. In lightly loaded internal walls, maybe not. I prefer to have them in because you've usually got finishes in there and you need a protection component for the finishes. But we've got a paper on how you would go about reducing that reinforcement and where you should take care and keep horizontal reinforcement. The other big issue with these walls is the core filling. Just like normal walls, you're filling them from the top. You've got to be very careful with the congestion levels of reinforcement in these walls. So what we're doing is generally these walls are fairly lightly reinforced, and at that light reinforcement level we've got special mix designs that have additional workability so that we can increase that flowability and workability of the concrete so that we can get that compaction into the concrete with limited vibration. At higher reinforcement levels, we go to these higher workability mixes. So typically we're down around about the 140 mil slump, but we will go up to 170, 180 mil slumps where you've got high concentrations of reinforcement. And then the comparisons that we've done really here have been just for the basement walls, the retaining walls. But these systems are being used in all sorts of types of walls in buildings. Especially in the residential industry where we've got a lot of walls already in the building, but also in other markets, in the office and retail spaces where you've got the back of house areas, these permanent formwork systems are being used. In retail, Coles is now using the PVC for their loading docks and just back office areas. The PVC systems are sort of intended, the finish is what you get. They can be painted, they can be rendered, but in general they're left unfinished. The fibre cement systems, they're intended to be an architectural system that they can be set and finished with a skim coat, paint finish, full render to get that level of finish that you need for a wall. And what you can end up with is a very thin finished party wall that still achieves all the fire and acoustic ratings for a building. And they're being used 4 lift shafts, 4 deep beams, singly reinforced, doubly reinforced, depending on the size range, and the size ranges are increasing. Another aspect that once we get above the ground that I see in the industry now is these walls are being used as columns. And I've been terming them blade walls, blade columns. And it needs care. There wasn't a good definition in AS 3600 on what the difference is between a column and a wall when you change over. The old 4:1 or 8:1 ratio, well, that's only actually in the fire section. It's nothing to do with capacity. So what I've always said is the European definition. The simple wall formula in section 11 is really intended for concentrically loaded continuous walls without any tension in them. As your walls get shorter and isolated, you get potential for eccentricity, you get potential for tension coming into the faces. At some point, you're going to be changing over to a column design and all that entails, double reinforcement ties. So I've been using two terms, a blade wall and a blade column. Blade wall it's long enough to be designed using the wall section 11. Blade column, you've triggered section 10. AS 3600, the new release of that, has got new restrictions in there, so you're triggering that changeover to section 10 column design a lot earlier now than it was under the old 2005 code, 2007. Another issue that needs to be addressed is that with in situ walls, the inspection criteria has traditionally been with the face open on the formwork, so you can inspect all that steel work. Thanks. With these walls, you don't have that opportunity for the main part of the wall. But in general, these are simple walls. They're uniformly reinforced, equal reinforcement, or uniform reinforcement. So you can get a fairly substantial check from the top. But the other thing we've done is the corners are open now, so that the corners can be temporarily taken off, slid off, and you can actually inspect the corners, which is the most critical location. Another aspect of corner design that's often overlooked is the congestion in the corner can be critical. And the biggest mistake that I see, even in situ walls, is the lapse of those corner bars, the U-bars, going into the corner. If you've got a sort of 1 or 2% reinforced wall, then you can end up with 4 or 5% steel ratio in that corner, which makes it impossible to fill, to get proper concrete in there. So even in situ, but especially with our walls, you pull those laps back so the bars aren't lapping into that zone. So there's a lot of little detailing things that we've got, that we've worked out over the years, and we can help you with. We've also got all the standard certification along with code mark. But fundamentally it's a reinforced concrete wall, so we're certifying the formwork, but the actual design of the wall itself is being covered by the project designer and his design of the wall. And I'm part of the CSR technical support. I'm doing a lot of R&D on these systems. We've got testing happening out at the University of Western Sydney. We've got a factory down in Goulburn where we're doing just in-house testing. We've also got a factory out at Minto that has a bit of room that they let us use sometimes for testing. And we've got all the facilities of CSR, so we've got all the test facilities at Wetherill Park. So we've got the full technical support of CSR for all their CSR products and the how to tie them into these systems. So if you need any technical support or you've got any detailed questions, I hope I can answer them for you. That is very quickly an introduction into these walls and how you would just substitute with block work but you can do the same with precast, in situ,